Here we are. Here we are. Who wants to say hi to YouTube Nation? Why don't you?
Hi.
Hi to who?
Hi, YouTube Nation.
Hi, Lindsay.
Lindsay Ream? Why do you say hi to her? I'd say hi to Sarah Savacool. Sarah Savacool is way cooler than Lindsay Ream. See if they watch and they get mad tomorrow. See if anybody actually really watches this. Okay, here we go. So, no, there's people who watch them. All right. Law of cosines application. So, you have a test on Friday. I've got a study guide all ready to go for you. I'll hand it out right as soon as class is done. Friday. We're all done with it. I told you it's going to be a quick unit. All you got to do is use the law of sines, the law of cosines. You know how to do that, right? Some of you have not done your homework, it looks like. So, we're going to try kind of a difficult problem right now. It says point A is due north of point B. From C, or of C from B. Should be a what in here. What is the bearing of C from B? What is the bearing of C from A? So we're going to spend more time talking about bearings tomorrow. You'll have a little bit of work, time. The question is, what does that mean, bearings? Well, for example, it says C from B. So you're starting at B. So another way to think of this is B to C. And that's the way that I'll write it on your test and on your homework or on your study guide. C from A, so A to C. So let's just think about it, okay? And then we'll go to work here. If I have a compass, straight up points north, 0 degrees. This is east, or 90 degrees. This is south, or 180 degrees. And this is west, or 270 degrees. Now, some people don't like that because it's different than our coordinate plane, right? Well, you got to deal with it. That's all there is to it. Okay, the coordinate plane goes counterclockwise. This goes clockwise, right? That's just the way it is. You just got to get used to it. So this is 0 degrees or 360 degrees. So if I were to take that shape right there, and I were to put it on B, okay, I'm going to go from B to C. If you were to describe the direction that I would travel to get from B to C, how would you describe that direction? Northwest. Everybody agree? So the bearing would be somewhere between 270 degrees and 360 degrees. So if you tell somebody to travel northwest, well, there's a whole range of, area that they could travel, right? You want to be more specific. So you're going to give them an exact degree. It's going to be somewhere between 270 and 360. Let's say I'm standing at A. I'm going to travel to C. Describe that direction. Southwest, somewhere between 180 degrees and 270 degrees. So we're going to find that. In order to find those angles, we have to find some type of angles within the triangle. Now we know that this line is straight due north because it says it's due north. So we need to find some angles. If I want to find some angles, I have 3 sides. What do I have to use? Side says I use the law of cosines. Yes! And which one will you solve for? A, B, or C? Which one do I choose first? B, why? It's the biggest. I choose the biggest one first. So we're going to solve for B. We have B squared is equal to A squared plus C squared minus 2AC times the cosine of B. That's my formula. Do you know B squared? 225 equals, what's a squared? 169, what's c squared? 144 minus 2 times 15 times 13 times cosine of b. I have to solve for b. Looks like I should get out a calculator. You know, sometime I'm going to have something up on my screen that's supposed to be like personal information for a student or something, and then all YouTube Nation is going to see it, and then I'm going to get fired. That's what's going to happen. And Casey will laugh and laugh and laugh and laugh. So 225 minus 169 minus 144. And I get negative 88. Equals 2 times 15 times 13 is 390. Negative 390. Everybody got that? So if I divide by negative 390, is cosine positive or negative? So you got 88 over 390 is equal to cosine of b. It's positive, so therefore is b going to be acute or obtuse? Acute, because it's in the first quadrant. Cosine is positive in the first, it's negative in the second. If it was negative, it would be obtuse. With cosine inverse. Cosine inverse of 88 divided by 390 is 76.96. Everybody okay with that? Any questions? Oh, I got that. How can I find another angle now? Law of sines. Set it up. Sine of 76.96 degrees divided by my opposite side, which is 15, is equal to the sine of A. I'm going to use A, because that's just what I feel like doing, divided by 13. And here I go. 13 sine 76.96 divided by 15. 1844, inverse sine of the answer, and I get 57.60. Can I find C? Yes. I can find C. Add them up, subtract from 180. 180 minus 76.96 minus 57.60. Enter. 42.44. What? Oh, gosh. Alex Yankee. Come on. All right. What do I got? Okay. Let's answer the question. It said, what is the bearing from B to C? Well, let's just think about it, you guys. If I were to walk straight north, what is that bearing? 0 or 360, right? How many degrees to the left of 360 are you? 76.96. So if I just take 360 minus 76.96, what does that give you? So the bearing from B to C is 283.04 degrees. You guys told me it was somewhere between 270 and 360, right? Well, we figured how much it was. We just subtracted our 76.96 off of that 360. That's all there is to it. Piece of cake. Upside down. Okay, so now if I want to go from A to C, what is A straight down to B? What's that? 180. Yeah, it's straight south. And you're turning 57.6 degrees past 180. So would you add it onto 180 or subtract it from 180? You'd add it. Very good. 180 plus 57.6, and you get 237.60 degrees. You guys told me it was somewhere between 180 and 270. Does that make sense? Okay, we're going to talk about bearings more tomorrow. But they don't generally give, this is what we call like a standard form of a bearing. Normally they say like north 37 degrees west. We'll talk about what that means. Okie dokie. Turn it over. Let's go to the other side. Yeah, sure, you betcha. A triangle parcel of land is 235 feet of frontage against the road if the other sides are 110, 165. What angles are formed against the frontage road? Let's draw a road. Let's have a contest to see who can draw the straightest road. What? My world has green in the middle and not yellow. Whatever. Okay, here we go. They want to know the sides. Or they want to know the angles. Angles against side. It says triangle parcel land. I drew it. 235 feet is frontage feet. Okay, it's against the road. It's up front. We got 110, 165. So I need to know angle A, this angle right there. I also need to know angle B, this angle right there. That's what I got to figure out, where those angles form. That's what it says. What do you do? Well, I have cosines. Can I start with A? No, you start with C because that's the bigger one. So we go to work. C squared equals A squared plus B squared minus 2AB cosine of C. As you can see, it looks very similar to the Pythagorean theorem. Law of cosines does. It just subtracts off something. So we go C squared, 235 squared equals 110 squared plus 165 squared minus 2 times 110 times 165 times the cosine of C. That accounts for some big numbers. Let's not write it all out. 235 squared minus 110 squared minus 165 squared equals 15,900. Equal to, let's see, negative 2 times 110 times 165 is negative 36,300. Now what? Divide. Is it going to be positive or negative? Is the angle going to be obtuse or acute? Obtuse, because cosine is negative in the second quadrant where everything's obtuse. Very good. You're smarter than you look. I said you're smarter than you look, Tara Westland. Yes, I did. I said that. Are you insulted? Just trying to get a rise out of you guys. If I don't insult you, you get bored in class and then you fall asleep. I only insult you to try to help you learn more. Okay, so 115.98. Isn't that excellent? Okay, it's obtuse. True or false? There can be more than one obtuse angle in this triangle. False. So we know that the other ones are going to be acute, so we don't really have to worry about anything when we do the law of sines. We don't have to worry about coming up with two solutions. So we just set up the law of sines. Sine of 115.98 divided by 235 is equal to sine of A divided by 165. You know, I got an idea. You know, we talk about taxing the rich or what else do we talk about? How else do we cure? Oh, cutting spending in Washington. You know, those are the big things that, you know, people argue about. You know, how do we take care of our debt? What if we made everybody drop a quarter into a box every time they insulted somebody? Yeah. Then we would have no debt, but we would all be in poverty. Very good. Yeah, okay. All right, I inverse sine of that. 39.14. And now I can find my other angle by simply subtracting from 180. 180 minus minus okay. Did I answer the question? Yeah, I did. I was just looking for the angles formed against frontage row, and I've got that 39.14, 24.88. Let me ask you guys this question, because this you got to think about the reality of the situation. Now, when I used to teach the regular track trig course and not the college track trig course, we used to have more time because we just had less material we had to cover. And we would always go outside about 7 to 10 times during the spring, and we would apply our trigonometry outdoors. And that may sound fun, but it was challenging. It was. It was great to be outside. It was awesome. I loved it. But we just don't have the time. Maybe if we really hurry up this year, maybe we could get to it. We'll see. But anyway, my point is this. If you were out in a field, could you conceivably measure the distance between 2 points? Yeah, 110 feet. You could pace it off, right? And if you didn't think your pacing was accurate, what you could do then is you could just get a tape, stretch at that distance. What about trying to come up with an angle of 39.14? Is that reasonable to look between 2 points and know it's an angle of 39.14? No, that's absurd. And so that's why, trigonometry can be so powerful within that regard. Last question. Can you now find the area of this shape? Yeah, you can do any option you want. 1/2 times any two sides, the product of any two sides, times the sine of the included angle, now will give you the area of that piece of land. Just like that. Which brings us to our final problem. It says, example 3, you will have a problem like this on your test, I promise you. This will be 6 points on your test. The southernmost boundary of a four-sided piece of land is a river. There's our river. We're going to put some fishies in there. It's a shark. That's a shark. My shark is in a river because it swam upstream from the Gulf of Mexico. What do you think? How do you think it happened? Do you think that sharks are born in rivers? That's insane. All right. We're watching River Monsters. It's a great show. All right. The other three boundary lines are 285. We got 98 degrees, 105 degrees. Now, I'm telling you right now that when you get this on a test, some people say, well, I can't tell Mr. Gintz exactly what's going on there because the directions aren't clear enough. I will make sure on the test that you have nice, clear directions as far as where to label stuff, okay? No big deal. And I won't give you such big numbers like 285 and 564, but you have to know how to approach this type of shape. And it says, you know, if this is the piece of land and you know, what shape is this, by the way? Okay, you all have to go back to geometry. Everybody fail. What's a... No. Quadrilateral. It has four sides. There's nothing else interesting about it, okay? You would have to have, like, two sides that are parallel in order to say something interesting about it, okay? All right. So, here's what you have. Now, do you have a formula to find the area of any trapezoid or of any quadrilateral? No. So you have to divide it in what shape? Triangle. So we're going to take our thing here. And I'm going to divide it like that. Do you remember the formula for the area of a triangle? Very good. 1/2 base times height, which means absolutely nothing in this situation because you don't have a 90-degree angle, so we'll get rid of that. Using trigonometry, we derived a new formula. Do you remember what it was? Excellent. 1/2 AB sine of C. Which means if you take 1/2 times the two sides times the sine of the included angle, you will get the area. So do I have two sides in the included angle for the triangle number 1? Yes. So what I could do is I could say that this is equal to 1/2 times 564 times 285 times the sine of 98. Take out my calculator. .5 times 564 times 285 times the sine of 98. 79,587.84. $79,005 what? So we got, you know, one triangle. Can we do the other triangle? Yeah, we're in trouble right now because all we have is this length right here. We don't have this length. We don't have that angle. First hour said we should just divide it in half. Does it look like it's divided in half? No, it's not even close. You can't just do that. I love that. You know, people are like, well, let's, you know, you'll have a triangle drawn and, you know, this base will be 10 and you drop down a height. And you're like, you know, what's this and what's this? They're like, well, divide in half, 5 and 5. What? I mean, I would understand if you maybe, you know, drew it just a little bit out of, you know, whereas like, you know, you're like, well, maybe it's isosceles. Some people, I know how they get in the class. All right, so here we go. So let's do this. We got to find a length. How about we find the length of this diagonal? What do you think? How do we find that? Law of cosines. Because you have a side, an angle, and a side. Side, angle, side says we use the law of cosines. That will help us find this. We set it up. We'll call it x. X squared equals. Now you guys, this is where everybody falls apart. Everybody says, well, I want to label everything A, B, and C now. Well, if you want to go ahead, I'm not going to do that. I'm going to use just what the formula says. It says I take these two sides squared, so 564 squared, plus this side, 285 squared. Then I minus 2 times the product of those times the cosine of the included angle. So, I mean, that's what it does. Who cares about A, B, and C? Think about the two sides and the included angle. That's what cosine does. Now, let's think about this. Cosine 98, positive or negative? Negative because this is the second quadrant. So you're going to subtract a negative result, so it's going to add more onto that. So if we just take the whole thing and type it in our calculator, 564 squared plus 285 squared minus 2 times 564 times 285 times the cosine of 98. Done. Oh boy, 444,000. What do I have to do? Square root it. Square root of your answer, and you got 666.38. Bad number. At this point, some people wanted to quit and say the problem was cursed. All right, we have two sides now, right? But we don't have the angle. But being we found this side, we now have an angle and its opposite side. If I have an angle and its opposite side, I can then use law of sines. We want to be able to find this angle. We'll call it alpha. In order to find it, we got to find beta first, right? We're kind of the fish realm, so. So we have the sine of 98 degrees divided by 666.38 is equal to the sine of what? No. Beta divided by what? 285. Cross multiply, solve for that. 285 sine of 98 divided by 666.38. Enter. Sine inverse of your answer, and I get 25.06. Everybody good? Now what? Subtract it from 105. So I'm going to subtract that from 105. $79.94. Do I now have enough information to use my area formula? Yes, I could say that triangle 2 has area equal to 1/2 times 666.38 times 322 times the sine of 79.94. That's going to be a big number. Who got it? Like, it's like 105,000. What do you got? So that's triangle 2, 105,637.68. So now I have to Add those together, and you get, so add the 79,587.84 onto that. .52. So I added the two areas together, I get 185,000 approximately. Or about 3 acres. So, you know, what can happen then is they can input these type of formulas into computers. So once they have these 3 legs, these distances, and the 2 angles, it will automatically calculate the rest and give you the area immediately. But this is the work behind it. What I want you guys to do is I want you to take, hey, where'd it go? Right here. What do you want? An acre? An acre is right around 60,000 square feet. I believe it's 56,000. I don't know. Take out your smartphone and Google it, for crying out loud. Well, you could take an acre and, yeah, make it a square. An acre is not confined to certain dimensions. It's confined to a square area. So you could have a rectangle or a square. It doesn't matter. There's your assignment. Write them down. You got 2 problems. Make the shapes. Find the areas, just like we did. Go, Gadget, go.